some tens of spectra in which appear two characteristic energies, okay? Also big gap, also small one. And so the tentative was to fit this spectra, very strange, as a sum, weighted sum of two BCS terms to account for this large peak and small peaks. Okay? And it worked out with very strange parameters, which resulted that the large gap would have more or less strong coupling limit of BCS, but the small gap would not correspond to anything related to superconductivity alone. It's too small. Okay? There were several experiments similar to this. This was how the gap closed at critical temperature, and for each temperature a fit was done with two gaps, and we needed both gaps to exist at least to 35 Kelvin, at which the precision of the experiment was not enough to count. But anyway, if we considered this as a superconducting gap alone, the critical temperature should be something like 12 Kelvin, and it was not clearly closing at this temperature. Another example, so this was a case of one of the most prominent cases of two-band superconductivity, in which in the materials there are two important bands that cross the Fermi level, and you have a gap opening in each band. Another example which was very important is related to high TC superconductivity, in which the gap width was shown to have no relation to TC. So here, for instance, it is overdoped sample, and you have 70 Kelvin critical temperatures, the gap is very large, and then you have also 70 Kelvin sample, but overdoped, and the gap is very small. This is Miyakawa-Zazinski group from Chicago University and Argonne National Lab. And basically, depending on doping, the 2 delta over KBTC ratio, BCS ratio, varied from 4 to 20. And 20 is something really weird. And this was related to so-called pseudo-gap, and this pseudo-gap still remains an unresolved feature in superconductivity. Probably related, probably not to superconductivity, but certainly related to the closely lying antiferromagnetic insulating phase. By the way, while in all BCS superconductors the gap closes at critical temperature, in niobium it's 9.3, in BISCO it was still existing in TC and even going well above critical temperature. So let me stop here, and I'm ready for questions if they are. There were several questions before. But